We're working on this 2014 Ford Explorer. Our fuel rail is located right here, as well as under the intake. We have an electronic returnless fuel system with direct injection. We just removed our fuel pump relay, and so now what we'll be doing is we'll be starting the vehicle and seeing how long it'll run on fuel.
The relay is number 15. It says it in the owner's manual, fuel pump relay, and it's in the corner right here.
So once removing the fuel pump relay, the engine just stalls immediately. We have our amp clamp hooked up to one of our injectors. Now see what our readings are on the picoscope. And you can see periodically there's a, let me see if I can stop this. You can see right there our dip as it increases and then just drops with our amperage. We have this 2017 Hyundai Sonata with the same fuel system as the Explorer. And so we're gonna be removing this intake so we can get to the fuel rail below it, and we'll be removing that. We almost have the intake removed. There were 3 bolts on top. There was a bracket on bottom, and we disconnected the throttle body from the side of the intake. Now what we're doing is we're removing these connectors from the intake so we can take the whole thing out.
So we got the intake manifold taken off. Now we have access to the fuel rail. It is electronic returnless. And then we also have access to the high pressure fuel pumps. We got everything disconnected. This fuel line over here is disconnected. We're assuming that this has never been taken off, so we're trying to pry it off, but it is kind of hard to do. So we'll see what happens. Layers on.
Pulled our fuel rail off with our injectors. 2 of the injectors, this one as well as that one, were stuck when we pulled the rail out. So here you can see the injector itself. You can see our different O-rings. We got this one here, this blue one.
Also, these normally would be one-time use. This would be no one-time use, and then this is like multi-use, but
you'd want to replace it.
Yeah, so we would be replacing the injectors anyway, since normally you can't find like the seals sold separately. So normally on non-direct injection cars, you'd be able to bench test these, but since it's direct injection, there's no way to like conventionally bench test these. If we were able to, we figured that these 2 on the end probably wouldn't flow as well. If I can get it to focus. They are more gunked up than these 2 on this side. But we're going to do our best to clean them up. We'll lube them up with dielectric grease. We're going to clean out the ports in there because they're really corroded. You can see kind of the corrosion all over the fuel rail. And then normally if you had them out, you would get your like valves and intake port walnut blasted to clean all of this like soot out, but obviously we're not doing that today. We just cleaned it with carb cleaner and a shop towel, and we're gonna grease up all the injectors with this weird looking grease. Weird. Yeah, bro. We press it in as far as we could with our hands, so we're gonna try and use the bolts to kind of pop them back into place.
Rail and all of our injectors installed. We just put the connectors to all of our injectors and also the fuel rail on here. Now what we'll be doing is we'll be reinstalling the intake, putting all of our connectors back on, as well as the throttle body. So on this intake you have a couple connectors, this one here, one there. Your wiring harness clips in in these different areas here. So you just have to take note of that. And you want to make sure that your wires, the way that they're laid, that they're not covering up anything or interfering with something. So here we found a lab vehicle that is multi-port fuel injection.
There you go. Now we want to probably take the auto. You need to attenuate, which you are. That's good. Now, if you take your trigger, go to repeat, put your trigger up a little bit. There you go. Now, you have to zoom in on your signal. So go to your zoom window.
What happens if you put the trigger thing higher?
It may not catch that if it doesn't go that high. There. Now you're getting it.
The frequency of these just got faster. And currently we're testing the voltage readings and the voltage spikes. And so here you can see we're reading our alternator voltage. It's around 15. And then you can see when it's pulled to ground and turned off, and our magnetic field collapses and it spikes up to around 115, 120 volts.